Okay, so today we're going to learn a couple of basic constructions. These are the very bare minimum ones you'll need for this class. There's a chance that in the future, if you go into like actually teaching any of this stuff, you'll need to know how to do more constructions. If that's the case, I'd highly recommend this website as a resource, or if you need any help with any constructions, even on any of the homework assignments in this class, it is mathopenref.com. It will do a step-by-step description of every construction you could potentially think of. So I definitely would recommend this as a website if you need any additional help with constructions. That being said, we're going to go ahead and do 6 different basic constructions. One we actually already did on the sketch, draw, and construct video, so we aren't going to spend too much time on the equilateral triangle, but there are 5 other things that we need to know. Let's go ahead and get started. First thing we want to be able to do is to copy a segment. In order to copy a segment, we first need to draw a segment. Let's go ahead, just draw a generic segment. I'm using this as a straight edge, I guess. I don't know where my ruler went. There we go. There is a straight edge or a segment. I'm gonna go ahead and call this PQ. In fact, how I would write this in terms of line segment PQ would be PQ with a little line over it. Now, if I want to copy this, I just need another line with the exact same length. So what I'm going to do is I'm going to actually draw a beginning vertex. I'll label it R. I want to prove, by the way, that PQ is congruent to RS is what I'm going to do. So I got to figure out where S is going to go. I'm going to get out my compass. Remember, pointy end goes here, and you can move the width of the pencil in and out until it matches up. By the way, my pencil isn't very sharp. If you sharpen your pencil, or if you have a brand new compass, it's probably came with a sharp pencil. That's going to be helpful. So anyway, got the width of PQ, so I'm going to go over to R, and I'm going to draw an arc. It does not matter where on the arc you put the dot S. Notice every single place on this arc is the same distance away from R as Q was away from P. Then you'll grab your straight edge. You'll connect the 2 dots. I'm going to go ahead and label S here. And I just copied the segment. PQ is congruent to RS. We will also need to be able to copy an angle. So that's going to be our second thing. Just like when we are going to copy our segment, this means we need an angle to copy. Go ahead. You can draw just a generic sized angle. I'd probably recommend an acute angle. Don't make your rays too small, but obviously you don't need them taking up your whole note page either. Maybe something like this. In fact, I'm going to go ahead and label the endpoints so I can label this angle with letters. So I'll do ABC. So what I'm going to do, my directions are going to be, I want angle ABC to be congruent to angle, well, let's do JKL. So I want to copy this angle. First thing I want to do is I want to use my compass, put the point on the angle itself, so B is the angle. Make sure that it is shorter than both the endpoints of A and C. If it's too long, even if it's shorter than the one but it's longer than the other, it's not going to work. So I usually go maybe about halfway, maybe a little bit longer. My angle rays weren't as long as I've done in the past, but as long as they're it's somewhere in between B and C and B and A, you'll be fine. I'm gonna go ahead and I'm gonna sketch this angle. Don't touch your compass. Keep it that same width. Go ahead, sketch in the bottom ray of our new angle. Again, doesn't matter how long. The angle that we are trying to copy is the distance that it is open. It's the space here. It's not, has nothing to do with how long the rays are. Now, if your compass is the same width as it was when you drew this arc, go ahead and draw an arc on this vertex. Just like that. Now, I'm going to draw little dots here so you can see what I'm referring to. You don't need to draw these dots in, but this is an important point. That's where it intersects. The arc is intersecting the bottom ray of our angle, and this is where it intersects the top ray. Go ahead, put your compass on one of those intersection points, and then close it or open it if you need to, depending on the size of your angle, until it would intersect this way. In fact, that needs to be really small. Dang. There we go. So you can see here, I'm intersecting that. So I found the width from here to where it intersects. That's going to help us because if I go to this intersection point and I draw that arc in, I'll know that if I go through here, it's going to be the same size. Let me go ahead. There's where it intersects. I'm actually going to put a dot there. I think it can be helpful. So I'm trying to connect this vertex and this dot. There we go. And I'm going to go ahead and label. So this point is going to be J, this point will be K, and this point will be L. Order does make a difference. We're going to talk about that more when we get to triangles. But notice I started on the top with A, went to the middle with B, and then across with C. So I have to start on the top with J, because that's the first one, go to K, and then L. I have to follow the same pattern. Next, we're going to learn how to bisect an angle. Now, what does bisect mean? It means we're literally going to divide it into two congruent parts. In this case, we're dividing the angle. But we can also bisect, for example, a line segment. We can split it into two equal parts. In fact, we're going to see that in the next construction. In order to bisect an angle, just like before, we need an angle. Go ahead. I would maybe recommend a little bit larger than this acute angle. Otherwise, you're going to be cutting it in half and it's going to be pretty small. I'd still probably recommend an acute angle though, so less than 90 degrees. Maybe something like, that looks pretty good. Okay. Let's see, I'll call this TUV. So I want to be able to cut this exactly in half. We're going to have this line going through, cutting it in half. We're going to start out the exact same way as when we copied our angle. I'm personally going to widen this a little bit. I had it narrow from doing the intersection points up here. So I'm going to do this, but again, make sure that it is shorter than my T and my V. Something like this. Do not touch the width of your compass. There's so many times where you aren't touching it. You're using this ultimately to measure without numbers. So you don't want to switch your measurements in the middle of a construction. Go ahead, put the point on the intersection point of the arc with the bottom ray of your angle. And draw an arc through the center of the angle. Similarly, keeping it the same width, go up here where the arc intersects the upper part of the angle and draw an arc through the center of the angle. This intersection point right here is exactly in the middle. You didn't change the width of your compass, and so therefore the distance is the same. We'll learn why this is the case when we get to triangle congruences in the future. But I can connect that point from my U vertex, and basically this is now congruent to that. We split it exactly in half. We bisected that angle. I told you we're going to bisect a segment next. I'm going to flip to a different piece of paper here quickly. So for our fourth construction, we're going to do the perpendicular bisector of a line segment. Not only are we bisecting the line segment, we're going to make sure we do it at a 90-degree angle because of that word perpendicular. This is one of the easiest proofs, I think, but it does involve a little bit of space. So definitely don't try and squish it on the bottom of your paper. First thing we need is a line segment that we're going to bisect. So I'm going to go ahead and draw my generic line segment and put 2 vertices there. Now what we're going to do is I'm going to widen my compass to the width of this line segment, just like this, till it goes through that point. There we go. And then I'm going to make a mark above the line and a mark below the line. By the way, if your marks aren't long enough, you can always go back and redo it. Just make sure you don't change the width of your compass. Let's go ahead. I'm going to put this on the other point and do the same thing. Mark above, mark below. Those intersection points will form the 2 points of a line that will perpendicularly bisect our line segment. I'm going to go ahead, put my straight edge up next to these, and connect. This distance is the same as this distance, and this angle, technically all 4 of the angles, are 90-degree angles. So you just bisected the line segment at a 90-degree angle. The fifth construction, I'm not going to take too much time to go over because we already did this in the sketch versus draw versus construct video, but it is an equilateral triangle. Ultimately, it's going to look like the top part of the perpendicular bisector that we just saw. You just aren't going to need this bottom part. You'll just need this top part like that. Let's go ahead and do it. I'll sketch a generic base to my triangle. I'll use my compass to measure. Let's see, too big. There we go. And then I'll make a mark above from this vertex, make a mark above from this vertex, and I'll know that that's the 3rd vertex of my triangle. Of course, I need to complete the triangle with my straight edge. So I'll connect the 2 vertices. There we go. Last construction is my favorite. It usually ends up being a lot of students' favorites. I guess in college it's fun too, but especially when you teach this to like your middle and high school students, if you end up teaching any of those levels, because you can make some very pretty pictures. We're going to go ahead remember, just a quick reminder, hexagon means a six-sided figure. Regular, for those of you that don't know, technically means congruent sides and angles. So this would be a six-sided figure, but every single side is the same length and every single angle is the same measurement. I'm going to have to draw, just like with the equilateral triangle, a generic segment. Keeping in mind, I'm going to have 6 of these, so it's actually going to be quite large. There we go. First thing is exactly like the equilateral triangle. Go ahead, use your compass to get the width of this segment. There we go. Go ahead and make a mark above from both of these vertices. Label this mark C. This is the center of your circle. We're going to draw a circle, and that C stands for the center. In fact, I didn't touch the width of my compass. This is the radius. Notice I used it from here technically, but if I put the point here, it's still going to be the same. It's the radius. It's the distance from here to both of these points. Go ahead and draw. There we go. Construct, I guess, a circle, keeping your center at C. If you're keeping it at C, it should go through both of the points of the line segment, just like that. Your hexagon is going to actually be, the endpoints, the vertices of your hexagon are going to be on the circle. Don't touch your compass for this whole construction. I'm going to go ahead, put the point here, and I'm just going to do a mark where it intersects the circle. Then I'm going to move the point to that intersection point. Make a mark where it intersects the circle. Continue this process. Eventually, you should get back to the line segment you started with. Right there. These 6 points, you already have the 2 marked, but here's the 3rd, the 4th, the 5th, and the 6th are actually the vertices of your hexagon. So you can go ahead and you can connect the dots to make your hexagon. I'm going to turn my paper. It helps me line these up a little bit better. There's my regular hexagon. Now you may be wondering why I think that this is cool, or why middle schoolers and high schoolers think this is cool. Well, what you can do is when you go to make these marks, instead of just doing the little tick mark where it crosses, you could technically go through, and it should go through basically here. Go to this point, swipe it through both, and you get this. Continue this process, but always go through like the entire thing versus just where the mark is. Oops, sorry. Gonna continue this. One last one, and you'll see it makes a beautiful flower. In fact, if I would have just done that without connecting these, you'd just have the flower in a circle. And you can obviously stop. You don't have to go all the way out there. I often will have students color them in, erase these, even though, yes, they're construction marks. Technically, just going to there is fine. So that is why students really like these.